Hello, everyone. Today I'm going to show a demo of the ezLiveStreaming. ezLiveStreaming is a scalable and reliable live transcoding system. It's an open source one. And ezLiveStreaming is written in Go. It is designed to be highly scalable, reliable, and resource efficient. So what can ezLiveStreaming do? It can support live ABR transcoding. It supports HOS and dash streaming. And it provides a simple-to-use live transcoding API. It is going to support DIM protection, and I'm currently working on integrating Shaka Packager for that purpose. And ezLiveStreaming generates standard compliant HOS and a dash stream, which can potentially work with any video players. So ezLiveStreaming consists of 4 microservices that can be independently scaled. There is a API server, a job scheduler, a cluster of transcoding workers, and Redis data store servers. Here is a high-level the workflow of the architecture workflow of ezLiveStreaming. The API requests come into the API server, which can be creating new jobs, getting existing jobs, the status of existing jobs, stop and running job, and resume and stop the job. And all the job requests goes into the a job queue, which is essentially a AWS simple queue service queue. And the job scheduler periodically polls the job queue to get new jobs and then assign them to the live workers within the worker cluster. So inside a live worker, we have a worker application process, which is a long-standing process responsible for monitoring, creating and monitoring live jobs, and also reporting heartbeat and also status of jobs to the job scheduler. So for each live job, worker app create one instance of worker transcoder to execute live streams. The worker transcoder takes live RTMP input and output HOS and dash stream, including the media segments, HOS playlist, and dash manifest. And then the worker transcoder uploads all the stream data to the origin server storage that can be AWS S3 bucket or Google Cloud Storage bucket, GCS bucket, or your private cloud service bucket. And ezLiveStreaming store all the metadata, the job states, in Redis instead of in memory. And in such a way that all the states are kept in a distributed data store. It does not maintain any states of the live jobs. And this stateless design helps ezLiveStreaming to be highly scalable and easy failover. And here's a list of API methods it supports. We can create a new job. We can specify how we want to transcode and package our live streams. So we provide a request body, which is a JSON string representing the parameters. The parameters can be the stream type, dash or HOS, the segment format, fragmented MP4, impact ES, or CMAF. We can specify the segment duration, indicate whether or not to use low latency live streaming mode. We can also specify an array of video output renditions. And for each video rendition, we can specify the video codec, the frame rate, the video resolution, video bitrate, the max bitrate, and all sorts of things. We can also get the job status. We can get the status of all the jobs or a single job. For a single job, we need to specify the job ID. We can also stop an existing job, a running job, by giving its ID. And we can also resume a stopped job. And in this demo, I also provide a simple implementation of a UI-based demo for showing how we can do live transcoding with ezLiveStreaming. I'm going to show the demo next. So this is the demo UI. So before I start the demo, I will first build all the microservices, starting from the API server, and then the scheduler, and then the worker app, and finally the worker transcoder. So I'll start the API server, followed by the scheduler, and then the worker app. So we don't need to launch the worker transcoder. It will be automatically dynamically created by the worker app when new job is received. As we can see, the worker app registers itself with the job scheduler when it starts. And the job scheduler will assign an ID to each worker, each new worker. And this is the worker ID. And we also have the Redis COI. And this is the NGX server. We use an NGX server web server to serve the HOS and Dash stream, as well as hosting the demo UI. Now we have all the microservices started, and we can start the demo. So I'll copy paste the sample job request. We just see the job request. We will create a Dash stream, live stream, using fragmented MP4 segments. And using H.264, video resolution is 640 by 360. And also the bitrate, number of threads to encode is 2, GOP size is 2 seconds, and the encoding preset is faster. So I will create the job. The server will return RTMP ingest URL and also provide a playback URL. I'll just copy paste the stream key here. And I will use the OBS Studio for sending the live input stream RTMP. Let's go back to the microservices. This is worker app. As we see, the new job is created. Let's do a PS. We see the worker app created a worker transcoder process for handling this live job. And worker transcoder will create a FFmpeg ingest and transcoder for this job. And FFmpeg is listening on the ingest URL we just see. And we're ready to push the live stream, the source stream. Start streaming. Everything is good, I believe, yes. And let's see. Okay, we see the new job, new stream data. And we see the MPD file. We see the media segments, and we see the initialization segments. They are stored in the NGX, the web directory, web roots directory, which can be played directly in the demo page. I'll ignore this error message. And then we use Shaka Player to play the Dash stream. I'll hit play. We see the started. The stream started. It's playing, as we can see. Yeah. Yeah, that's all about the demo.